Hi, I'm George Fairbanks. I'm going to talk to you here about why it's hard to do software architecture within a modern 21st century process. The big idea here is that in the 20th century, our processes were dominated and focused on the system's design. Now, regardless of which process you were following, they all were really trying to make sure that your system's design was pretty good. In contrast, the 21st century, we focus on metaphors like factories and industrial production. And what we're optimizing for is actually a stream of features, either trying to get those features to come out faster or higher quality or more quickly into production. And what I've noticed here is that overall, the old saying is still true. What gets measured gets done. So in the 20th century, we were optimized for the design parts, and that is the part that we got done. And as we moved into the 21st century, as we started to focus on the stream of features, we were measuring the stream of features, whether it was quantifiably or not. And so we are in a very interesting situation where it's now relatively easy to get that stream of features going, but it's hard to keep the conceptual integrity that you get from software design. So let me show you two pictures of libraries. This first one is the Trinity College Library in Dublin, and you may see a lot of things that are interesting about this. The first is it's got some beautiful wood, and the books are leather bound and just look lovely up there. It's like a piece of history right there. But I want you to look at something different, which is notice how the books are stacked. There are bigger books on the bottom and smaller books on the top. You probably can see that. And you'll also notice that they are really jammed in there. Let's take a look at another library. This is one that's representative of libraries you might see in the United States. And the first thing you'll notice is, because I've just primed you to look at it, is that the books are actually of different heights. There's some white space on the shelf where some books didn't reach all the way up to the top shelf. And in fact, with these bookcases, all the bookcase shelves are the same height. What's going on here? So what's going on here is that when you build a system, you will have a dominant decomposition. This is language that comes from the aspect-oriented community in the 1990s. But I find it applies in system design all the time. So if you were imagine designing a library, you would have to decide whether you're going to pack the books in, and the good thing about that is that it would be very space efficient, or whether you wanted to make it efficient for people browsing. So for example, if you go up to a section that's on history, you'll find all the history books in one place. But the problem with that is the history books are not all the same size. So you're forced into a choice here, and you get one of two qualities out of it. You could either get the space efficient quality, or you could get the easy browsing quality. So that was a hard choice, but in other times you have decompositions of the problem that don't force you into a hard choice. You get sort of a soft choice. So when you're playing pool, you may have noticed that there are two different perspectives that are going on. And maybe you've even, if you're a novice player, these are more active in your mind than if you're an expert. The first perspective is, you're just trying to find a ball that you can hit and drop it into a pocket, sink it into a pocket. Okay, so just that first perspective of, can I find a ball and can I get that one in? And then there's the second perspective is, well, once I've done that, I'm supposed to be making it easy for me to hit the second shot. So when I was an undergraduate, my buddies and I would go, and one of the things we'd do is we'd hang around the student union and we'd play pool, okay? And we were never very good. But what I noticed is that we went through a progression where at first, all we were really trying to do was get that first shot in, okay? Then there was some gradual awareness that the ability to get that second shot in depended on what happened at the end of the first shot, okay? So like where the cue ball is positioned at the end of that. And then finally, that they were like, not only can I hit multiple balls on that first one, I have different choices there, but the way that I hit them determines where the cue ball ends up and makes it easier or harder to set up that second shot. Which then, as soon as you realize what the possibilities are, you start screwing up the thing that you'd gotten good at. That is, in an attempt to try to get ready for that second shot, you start doing a worse job at hitting the first shot. Now, finally, you get good enough at this so that you're reliably hitting your first shots and you're doing a better job at the second shot. The point I want you to take away from this is that if you get good enough at an activity, you may not have a hard choice in terms of the decomposition. You may be able to hold in your head two different perspectives on the problem at the same time. In this case, how can I go about sinking the first shot and all the things that I need to do to set myself up so I can hit the second and third and other shots, okay? But that requires mastery. It's not a straightforward thing. There's plenty of people out there in the world who are not very good pool players like me who are still like really working on that first step, which is, can I get that first ball in? So in the 20th century, we've had a similar sort of thing where we focused on one decomposition of the software process, right? We had concerns like, can we even build these things? We used waterfall processes to maximize the chances that we would actually build the thing. And we didn't have a whole lot of hardware, so we were trying to be economical with that, so our design was very important. That became the dominant decomposition of the problem. In the 21st century, we mostly use iterative processes, and partly that's because cost minimization is actually a big deal, right? That you want to try to build the thing as cheaply as you can. Of course, that was a concern in the 20th century, but if you're not sure you're going to be able to do it at all, the cost is a secondary concern. But really, these days, we've got cheap cloud computers that you can really rent for pennies an hour. And what we've noticed here is that the feature stream has become the dominant decomposition of the problem. If you talk to teams and you talk to them about their process, they talk about the features that they want to build and the sequence they want to build them and how much test coverage they want to have for those features and how quickly they can get them to production. So like pool and unlike the library shelves, this is a soft choice. Now, if you are a novice software developer, you're only going to be paying attention to the dominant decomposition, which is the stream of features. And you're just trying to get good enough at writing code so that those features go in and the test pass and you get it into production. And just the things you have to do, just the table stakes, if you will. But it is possible, because it's a soft choice like pool, that once you get good enough, you can actually do design and do the feature stream at the same time. In the 20th century, our processes were geared towards magnifying the effect that our best designers would have on the overall outcome. And that made sense because failure was very much an option. We're dealing with very limited machines and the problems, we hadn't solved them before. So we're just like, I don't know, can I build a big system that does that? And I've noticed that the architect at that time was treated as the craftsman, and there was a very strong flavor of the implementers as the brute labor. In fact, at some points in some processes, things were specified at a high level, and individual developers were just given a specification of some tiny little thing that they needed to build. Okay, so they were just very much a cog in the machine. So in the 21st century, things have changed. We are magnifying the effect of our process and our tooling. That is, we are trying to build a great factory that churns out software, rather than maximizing a particular software developer that we hold up as the architect and maximizing that person. So in the 21st century, like if you think about factories, you think about the cost of running the factory and how quickly the factory can produce things. And that's exactly what we're focusing on right now. Strangely enough, individual developers who used to be treated like brute labor are now held up as the craftsmen, okay? And in fact, that sort of makes sense if you think about what we just talked about, is that the true master developer is able to develop their feature stream and do a great job at the other qualities like design that have to happen and the second order effects, right? So they're able to sink the first ball and think about how they leave the table so they can hit the second and third ball. And the factory-like processes dominate here. When you take a look at these two different worlds, you can very easily answer, what are these teams worried about? Where in the 20th century, it's like, can I get this done? We better get the smartest person I can find and put them in charge of this project, okay? Magnify that person. In the 21st century, strangely enough, even though developers are held up as craftsmen, they're really just like another machine that's in the factory. The thing that's really dominant is the factory churning out software for us. So there was a quote that I remember reading about Kent Beck, and I can't find it, but it goes like this. Kent Beck, who was the guy who was instrumental in the extreme programming revolution, the agile software development, he pushed design patterns. He's done an enormous amount of good. He is probably the one who can best be credited for why we do integration testing and unit testing today. But he invented JUnit, for example. He was asked, when do you design in the context of extreme programming? And his answer was, I design every day. And I think that's true. I really do believe he designs every day. Kent is one of those people, and the people that he's surrounding himself with are the skilled craftsmen, right? The ones who are like the pool player who can both sink the first ball and think about what's going on with the second shot. But the question I always have is, what about the rest of the team? Can they even sink that first ball yet? How have they done in that skills progression? And if we ask them to think about features and ask them to think about design, what happens? Do they start making mistakes on the features, right? Like the pool player who's thinking about the second shot and makes a mistake on his first one. In some ways, I think about these processes, the agile processes, often as being tailored towards the people that we would consider the special forces in our military. Now, you'll notice these two guys here who have different kinds of weapons on them. Their uniforms look irregular. They've got a lot of facial hair. They've got, looks like different colored baseball hats on. This is not your standard, high and tight haircut military soldier. These people have gotten to be so good, they're masters at their game, that we've decided we want to relax the restrictions on them. So in the same way, I view XP as a great process for if you've gotten to this level, it is the way to unlock your potential. One thing that is compensated for the fact that the agile processes are really great for experts, but not so great for novices, is that sort of at the same time, or maybe a couple years delayed, there's been a wave of DevOps practices that have been regularized and they've been built into tooling, and they just do an amazingly good job. They've been wonderful. They give us quantifiable metrics about what we should be shooting for. For example, like how much test coverage do you have? What is your time between how long when you write the feature, or you receive the feature request, you write the feature, and you get it in production? You have metrics about how to do that. And you have a clear improvement path, which is to ratchet those metrics down, get them tighter and better. That represents a kind of progress that is measurable and improves the health of your project. The thing is, though, is that being really good at DevOps covers up for a whole bunch of other things that you might be doing a lousy job at. So for example, it is basically a statistical control process like you would have inside of a factory, okay? You are testing the outputs to make sure that they seem to be doing the right thing. And if you do a good enough job at testing the outputs, maybe you can slack a little bit and not do a great job at design, not have a very clean design, have a sort of a convoluted design. But you know what? You compensate with better and better testing. And so that is a weird kind of dangerous situation to be in. I want to draw a parallel here, and I hope you can follow me on this one. In the late 90s, I might have been one of the very last people in the world to go into a repair shop and have his VCR repaired. Okay, it's true. And when I walked in, the guy said, you might as well just buy a new one for the cost it's going to, for me to fix this thing. It's going to be like $100 and something for me to fix it, and it's $150 for you to go buy a new one. I go, yeah, but out of principle, I'm the kind of guy that likes to repair stuff. I mean, so if it's a little bit cheaper and perfect, let's go ahead and fix it. So he did. And like I said, I don't even know how much longer that guy was in business. So we are in a situation now where things that are incredibly high technology can be cheaper to throw away and replace with another one that we've manufactured through a factory process, because the factory process is so efficient. So the question you have to ask yourself is, with the unreasonable effectiveness of DevOps, in many cases where you've got mundane software development, even if you get to the situation where your convoluted bad design, bad architecture catches up with you and the team stops making any progress, you might have still saved enough time by following this DevOps practice with bad architecture. It might have been cheaper to build the system twice than it would be to apply architecture and keep it working well the whole time. I don't like the idea of that being true. I'm worried that might be true, because certainly, I don't like the fact that it's cheaper to buy a new VCR or the modern equivalent of a VCR. It's cheaper to buy a new thing oftentimes than it is to repair your laptop or repair your TV or repair a lot of things. Just replace the whole thing. So let's take a look at what the three major options you've got if you want to fit architecture into a 21st century process. I've given these sort of my names, but the ideas I think are fairly well agreed. The first thing is what I call sliced iterations. That is, on any given iteration for your team, I better toggle off my things so you can see this slide. There we go. Nope, that's not it. Let's see. Can I toggle off? There we go. I go. Sliced iterations is the idea that within a given iteration where you're usually developing features, you actually schedule other kinds of work. This is the multicolored backlog from Philippe Christian, and I think he's done a very nice job here. He divides the kind of work that you need to do in every iteration into 4 buckets. Okay, they either have positive or negative value, and they're visible or invisible. So the typical thing that people schedule are features, right? Put features in, and the team builds features throughout the week. But you know what? We all realize that if a bug comes in, it may preempt. If it's a high importance bug, I have to do that before I get to build more features. So he calls that a negative value, but it's a visible defect. I got to go fix that bug. But there's also the invisible stuff, okay? So it could be hidden architectural features. So I might be thinking about architecture and decide, yep, I need to do this thing to clean up some architecture or to make an architectural change. But there's also the negative value, which is because I didn't do the architectural fix last week, I'm sitting here with some technical debt. And what I need to do is actually schedule the work to clean up the code, even though it doesn't help the customers directly right this minute. It only helps the overall health of the project. Okay, so that's squeezing architectural work into an iteration. And I got to click on the right window, and then I can change. Okay, so the second idea is some variation on iteration 0. So iteration 0, if you guys have heard this before, is normally you have a bunch of iterations that you're going to do, and you build features in every iteration. But in iteration 0, it's a little different. What you do is you sort of get the lay of the land. You might scout out things and decide on an architecture. You might do some prototyping to figure out which architecture or which technology might work better or worse for you, okay? In a way, you can think about it as, I'm about to do iterative development, but let me do a quick waterfall before I do any of the iterative development, because I know how to get some of those big ideas under control, software design, technology choices, and so forth. I know how to do that within a waterfall. I'll scope it down, and then I'll get on to iterations. And that's way better than not doing that. The only real question it's left with is, we don't believe that you can do architecture once and then you never need to change it, or even technology. Technology packages change, or you might have bet on a particular thing and the world changes around you. The company goes out of business that was building that thing. So when the architecture changes or the environment changes, do you squeeze another waterfall iteration in the middle of your project? It's not really clear how you do this other than with iteration 0. So the third major way of doing this is what I call theory building, okay? Your typical process looks something like this, an iterative process, where you get a new requirement, you write a test case for it, you edit your code so that the test passes, and in the very simplest version of the iterative process, you do some minor refactoring. For example, the refactoring just to remove code duplication, okay? So what you would do instead, if you were trying to do theory building, is that you do the same 2 first steps, get the new requirement, write a new test case, okay? But then instead of just simply writing some code, the easiest code that would make that work, you ask yourself, does this new requirement challenge the existing theory? The way you're thinking about things, perhaps the way you're thinking about the problem domain, there may be a change there. Or does it change the way you look at the technology solution that you've chosen and your architecture? You might say, you know, I'm increasingly looking like I'm not doing client server anymore because of these new requirements coming in. So if you do find that this new requirement challenges your theory, then you want to go and revise your theory, and you write the code, revise the code to match the theory, okay? And that last step is very important. You're not just writing code to implement a feature. You're trying to keep 2 things in your head at the same time. You're trying to keep the theory in your head, and you're trying to push that into the code. And so this is very much like the person who's a master at pool. They are working within a dominant decomposition, which is features and iterations. However, if you can keep it all in your head and not get swamped by it, you're trying to keep the theory in mind, you're trying to keep the code from diverging too much from your theory. And that's the way I see as a practical way of fitting architecture into an iterative process. So what this lecture has been about how we do software architecture in the 21st century when our primary decomposition, the problem is a stream of features. There's a strong flavor of factories and automation and quantitative testing of things. And that's as opposed to the 20th century, we were focusing on the systems design. Now, software architecture really came in at the very end of the 20th century. That is, it became formalized and well understood in the mid-90s, say. So just as the factory-like processes that are decomposing the problem based upon features showed up, is exactly when we got really good at understanding software design. So that's kind of a shame. And so this is why we have such a challenge today. Here we are about 25 years later since most of the primary abstractions in software development were created, and we're still trying to figure out how we make adjustments to our process so that we can get both of them to work together.